Imagine millions of dollars and thousands of lives riding on a single stretch of highway. Now imagine that highway failing, or worse, the very materials used to build it erupting in flames before the road is even paved. When we build roads, we are playing with liquid fire and battling the hidden enemy of moisture. If you don't test for both, catastrophe isn't a possibility, it's a guarantee. Today we are breaking down the critical science of asphalt flashpoint testing and revealing the exact moisture and density tools professionals use to keep our infrastructure from crumbling. Welcome back to the channel. If you're new here, we are your premier source for all things material testing right here at Certified MTP. You can find all the gear we discussed today and more at our channel link below, www.youtube.com/certifiedmtp. Today we are tackling a massive topic in the world of civil engineering and paving: road safety. But we aren't talking about guardrails and painted lines. We are talking about the molecular and structural safety of the road itself. It all begins at the asphalt plant with a concept called the flashpoint. What exactly is a flashpoint? In simple terms, asphalt binder, the sticky black, highly viscous liquid that holds our roads together, is a petroleum product. Like all petroleum products, when it is heated to extreme temperatures, it releases volatile vapors. The flashpoint is the absolute lowest temperature at which these vapors will momentarily ignite, or flash, when exposed to an open ignition source. Why is this an absolute life or death metric? Because paving requires heat. To make asphalt workable, it must be superheated. If a paving crew, a transport truck driver, or a plant operator heats a batch of asphalt binder past its flashpoint, the ambient vapors can catch fire, leading to devastating explosions. Testing the flashpoint ensures that the maximum safe handling temperature is clearly established long before the asphalt ever leaves the refinery. To determine this critical temperature limit, material testing labs utilize an asphalt flashpoint tester. The most common method used in the paving industry is the Cleveland Open Cup method, governed by ASTM D92 standards. Here is exactly how this vital test is performed. A technician fills a specialized solid brass cup with a sample of the asphalt binder. This cup is placed over a precisely controlled heating element. A thermometer is suspended directly into the sample to monitor the temperature continuously. The heater is turned on, and the temperature of the asphalt is raised at a steady, specific rate, usually a few degrees per minute. As the temperature climbs, the asphalt begins to off-gas. At strictly timed intervals, a tiny test flame, often referred to as a wand, is mechanically passed over the surface of the open cup. The technician watches closely. At lower temperatures, nothing happens. But as the heat intensifies, the vapor concentration above the liquid thickens. Eventually, the test flame passes over the cup, and suddenly, poof, a brief blue flash of fire dances across the surface of the asphalt. The exact temperature recorded at that exact millisecond is the flashpoint. By knowing this number, engineers establish the safe paving temperature, ensuring it stays well below the flash danger zone. But safety doesn't stop at fire prevention. Once the hot asphalt is safely mixed and laid down, a new, quieter enemy takes over. An enemy that destroys roads from the inside out: moisture. A road that doesn't catch fire is great, but a road that washes away in the first heavy rainstorm is a total failure. Water is the undisputed arch nemesis of asphalt and structural base courses. If the soil or aggregate base beneath a newly paved road contains too much moisture, or if it isn't compacted to the right density, the foundation will shift. The pavement will crack, rut, and eventually collapse into potholes. To prevent this structural failure, geotechnical engineers and field technicians rely on an arsenal of highly precise moisture and density testing equipment. Let's dive deeply into 4 pieces of essential equipment that ensure the ground we drive on is fundamentally sound. First up in our moisture-fighting lineup is the 𝐒𝐿 moisture tester. This is a rugged, highly portable device designed specifically for fast, accurate field testing of soils, aggregates, and even concrete testing sands. The 𝐒𝐿 operates on the proven calcium carbide reaction method. Here is how you use it. A technician takes a precisely weighed sample of damp soil from the job site and places it inside the heavy-duty cast aluminum pressure vessel of the 𝐒𝐿. Next, they add a measured reagent, calcium carbide powder, along with a couple of steel pulverizing balls. The vessel is sealed tight, and the technician shakes it vigorously. As the steel balls break up the soil, the calcium carbide chemically reacts with the free moisture trapped inside the sample. This chemical reaction produces acetylene gas. As the gas expands, it creates pressure inside the sealed vessel. The built-in pressure gauge directly translates that gas pressure into a percentage of moisture content. Within minutes, without needing a laboratory oven or a power source, a crew chief knows exactly what the moisture content of the soil is. If it's too wet, they must dry it out before paving. If it's too dry, they must add water to achieve optimal compaction. The 𝐒𝐞𝐫 𝐂𝐞𝐫 is an absolute workhorse that prevents road bases from failing before the asphalt is even poured. Now let's step into the realm of advanced, high-tech, non-destructive testing with the Instratech Explorer 3500 nuclear soil moisture density gauge. While the 𝐒𝐫 requires taking a physical sample, the Instratech Explorer allows engineers to test the ground exactly where it lies in a matter of seconds. This machine is an industry standard for measuring both the density and moisture of soils, aggregate bases, and the final asphalt pavement. Nuclear gauge sounds intimidating, but the science is brilliantly effective. The Explorer 3500 contains a shielded radioactive source rod, typically americium 241/beryllium and cesium-137. When the technician lowers the source rod into the ground or rests it on top of the asphalt surface, it emits a known quantity of gamma rays and fast neutrons into the material. The gauge then counts how many of those rays and neutrons bounce back to the detectors. Here is the genius part. Gamma rays are absorbed by dense materials. So the fewer gamma rays that return to the detector, the denser the asphalt or soil is. Meanwhile, fast neutrons are slowed down by hydrogen atoms, which are found in water. By measuring the slowed neutrons, the machine accurately calculates the moisture content. The Instratech Explorer 3500 is beloved in the field because it features an incredibly intuitive keypad, a backlit display for night paving operations, and built-in diagnostic routines to ensure flawless operation. By providing real-time data, roller operators know exactly when the asphalt has reached maximum compaction, ensuring a watertight, durable road surface that will last for decades. Moving back to chemical testing, we have the legendary Speedy 2000 moisture tester, specifically the model designed for a 20-gram specimen weight. The Speedy brand is synonymous with reliability in civil engineering. Like the 𝐒𝐞𝐫 𝐂𝐞𝐫, the Speedy 2000 utilizes the calcium carbide gas pressure method. However, the 20-gram version is specifically engineered for finer materials. When you are dealing with fine sands, specialized soils, or specific aggregate blends where a smaller, highly controlled sample provides superior accuracy, the 20-gram Speedy is the tool of choice. The kit is an entirely self-contained laboratory in a box. It comes with a highly sensitive electronic or mechanical balance to ensure you have exactly 20 grams of material, no more, no less. You place your 20-gram sample into the die-cast aluminum vessel, add your reagent, clamp down the top, and shake. The dial on the bottom of the Speedy 2000 reads out the moisture percentage instantly. The beauty of the Speedy system is its precision engineering. The seals are robust, ensuring absolutely zero gas escapes during the vigorous shaking process, guaranteeing that the reading you see on the dial is mathematically flawless. It is fast, it is accurate, and it requires virtually zero training to get repeatable, professional-grade results on any job site in the world. Finally, we need to talk about the unsung hero of these calcium carbide moisture testing kits, the 𝐂𝐴quacheck pressure gauge. Whether you are using a 𝐒𝐿SON or a Speedy, the entire multi-thousand-dollar road project relies on one single thing: the accuracy of the gauge reading the acetylene gas pressure. If the gauge is wrong, your moisture data is wrong, your compaction is compromised, and the road will fail. The 𝐂𝐴quacheck pressure gauge is a precision-engineered replacement and calibration part. Over time, field equipment takes a beating. Gauges get dropped, vibrated in the back of pickup trucks, and exposed to extreme temperature swings. This specific gauge is manufactured to the highest tolerances in the industry. It features a heavy-duty brass Borden tube mechanism inside, providing highly responsive and perfectly linear readings. It's calibrated to directly correlate gas pressure to the exact percentage of free moisture. Having a pristine, highly calibrated 𝐂𝐴quacheck pressure gauge ensures that when the needle stops moving, the engineer can sign off on the paving project with absolute 100% confidence. It's a small part, but it carries the weight of the entire project's success. At the end of the day, building a safe, lasting road comes down to two things: controlling the heat with precise flashpoint testing and defeating moisture with the right equipment. If you found this breakdown valuable, please subscribe and like this video. For all the professional testing gear we covered today, check out our channel at @CertifiedMTP. Keep testing, stay safe, and we'll see you on the next job site.